So, picture this scenario for a second.
Okay, I'm picturing it.
You're sitting on your couch, just scrolling through a marketplace on your phone, and you spot this incredible vintage leather jacket,
Oh, nice.
right? So you hit the buy button, you punch in your credit card details, and you watch the funds literally leave your checking account.
Yeah, always a little stressful.
Exactly. There's that brief moment of anxiety, sure. But fundamentally, you're operating with this massive invisible safety net right beneath you.
Right, because of the bank.
Exactly. Because if 2 weeks go by and the seller mails you, like, a cardboard box filled with gravel instead of that jacket, you are completely out of luck.
No, you just dispute it.
Yeah. You pick up the phone, you call your credit card company's fraud department, you initiate a chargeback, and a human being on the other end of the line arbitrates the dispute.
Mm.
The So, picture this scenario for a second.
Okay.
Going through a marketplace on your phone, and you spot this incredible vintage leather jacket,
Oh, nice.
right? So you hit the buy button, you punch in your credit card details, and you watch the funds literally leave your checking account.
Yeah, always a little stressful.
Exactly. There's that brief moment of anxiety, sure. But fundamentally, you're operating with this massive invisible right beneath you.
Right, because of the bank.
Exactly. Exactly. Because if 2 weeks go by and the seller mails you, like, a cardboard box filled with gravel instead of that jacket, you are completely out of luck.
No, you just dispute it.
Yeah. You pick up the phone, you call your credit card company's fraud department, you initiate a chargeback, and a human being on the other end of the line arbitrates the dispute.
Mm.
The money gets reversed. You're made whole.
It's totally seamless for us.
It is. And we take this entire apparatus of, human-managed recourse completely for granted in our daily digital lives.
We really do. I mean, the entire architecture of modern global commerce relies on that underlying threat of reversal and human arbitration. Right. It's a system built fundamentally on identity and legal consequence. You can sue a person.
Yeah, there's a real person there.
Exactly. You can ban a registered merchant account. You can track a physical shipping address.
But, and this is where today's deep dive comes in, step into the reality of the emerging machine economy. And that comfortable human safety net it evaporates instantly.
Instantly. It's gone.
We are crossing this threshold right now where artificial intelligence is no longer just...
To the blockchain.
So our mission over the next hour or so is to tear down this...
To the blockchain.
So our mission over the next hour or so is to tear down this concept known as the Agent Commerce Protocol, which is just the plain English name for ERC-8183.
A lot easier to say, too.
Way easier. We're going to explore why this highly specific, incredibly modular piece of smart contract infrastructure is being positioned as, well, the missing keystone for a self-sustaining AI economy.
We'll look at the granular code-level mechanics of how it actually functions, too.
Right. And, perhaps most importantly, we're going to explore the massive turf war brewing in the background.
Oh, yeah, the big tech clash.
A war deciding whether decentralized permissionless cryptography or the traditional walled gardens of big tech will ultimately dictate the rules of machine commerce.
And the stakes here extend far beyond just the crypto-native ecosystem or, the AI research labs.
How so?
Well, the financial volume projected for this specific type of autonomous commerce is just massive. And it's approaching much, much faster than traditional financial institutions are prepared for.
So if you are an investor trying to spot the next foundational layer of the internet, or if you're an enterprise developer tasked with integrating AI into your company's legacy systems,
Or even just an observer.
yeah, even if you're just watching the AI revolution unfold and wondering where human labor fits into a world of software hiring software, this deep dive is for you. Because understanding how autonomous agents will securely buy, sell, and verify digital services is the ultimate key to grasping the future of work itself.
Let's ground this in the macro data provided by our sources before we dive into the cryptographic architecture, though.
Yeah, let's look at the numbers.
The scale of the transition happening right now is difficult to overstate. Gartner's latest projections indicate that a staggering 33% of all enterprise software applications will feature deeply integrated agentic AI capabilities by the year 2028.
Wait, 33%. By 2028?
From software as a passive tool to software as an active employee.
Wow.
Furthermore, Deloitte's market analysis estimates that the global market specifically for agentic AI operations will hit $35 billion by 2030,
35 billion.
with 75% of Fortune 500 companies actively deploying capital into this category before the end of this current fiscal year.
Okay, let me stop you there. Because when we say agentic AI, I think we need to be crystal clear about what that actually means for the listener. Good point. We are not talking about a language model waiting patiently in a browser window for you to type a prompt.
Oh, not at all.
An agent has agency. It's a system equipped with a continuous loop of perception, reasoning, and action. So, like, an agentic system in an enterprise environment might be instructed to optimize our cloud storage costs.
Right. And then it just goes and does it.
Exactly. It independently monitors server loads, it reads API documentation from Amazon Web Services, writes a script to migrate data, and executes that migration without asking you for permission at every single step.
The independence of the execution is the defining characteristic here. And to facilitate that independence, an entirely new stack of communication and action protocols has been built at just breakneck speed.
And the sources highlight a few of these, right?
Yeah, the source documents highlight several foundational pieces. So Anthropic's Model Context Protocol, widely known as MCP, is a prime example.
MCP, right.
It's an open standard that allows AI applications to securely connect to external data sources and tools. Think of it as a universal adapter for AI to read your local files, query a database, or search a specialized corporate intranet.
And people are actually using this.
The adoption rate has been parabolic. It is currently deployed across tens of thousands of organizational servers, and its protocol is this fascinating piece of infrastructure that allows AI agents to attach automated micropayment level stablecoin transfers directly to HTTP requests.
So they can pay for things instantly.
Right. And by late 2025, that single protocol had already handled over 100 million automated machine-to-machine payments.
Okay, so if I'm listening to this data dump, my immediate reaction is going to be, wait a minute. If the agents can already talk to each other using Google's A2A, and they can read external tools using Anthropic's MCP, and they can send each other stablecoins using Coinbase's by 402, hasn't the problem already been solved?
Oh, that is exactly what you'd think.
Right. It sounds like the machine economy is already built and functioning perfectly.
But that is the exact illusion that the crypto slate analysis just tears apart. All of the protocols we just mentioned, MCP, A2A, by 402, they are incredibly sophisticated solutions to a very specific singular problem.
Which is?
Authorization.
Okay.
They are designed to answer questions of permission, like, does Agent A have the proper security clearance to access this database? Or does Agent B have sufficient funds in its wallet, and did its owner authorize it to spend $2 on this API call?
So they're just access control mechanisms.
Exactly. Access control. What they completely and totally ignore is verification.
Authorization versus verification. That is, that's a massive distinction.
It's the whole ball game.
Okay, let's unpack this.
Yeah.
It's like authorization is the bouncer at the door of the nightclub checking your ID to see if you're allowed inside.
That's a great analogy.
And verification is the bartender making absolutely sure they mixed your drink with the correct ingredients before they take your cash.
A perfect distinction, yes. The current generation of payment incumbents, the traditional financial heavyweights, they are aggressively building architecture for agentic commerce, but they are entirely focused on reinforcing that bouncer at the door.
Because that's what they know how to do.
Exactly. They're building authorization layers because that is what traditional finance understands. Take Google's Universal Commerce Protocol, or UCP.
Okay, what's that?
They've assembled this massive consortium, including Shopify, Walmart, MasterCard, Stripe, Visa. The goal of UCP is to standardize how an AI agent navigates a live traditional e-commerce checkout flow on behalf of a human user.
Okay, so if I tell my personal AI assistant, go buy me the cheapest brand name paper towels available online, UCP is the standard that allows the AI to put the item in a Walmart digital cart and seamlessly pass my stored credit card information to the payment gateway.
Right, without triggering a bot prevention captcha or getting blocked.
Wow, okay.
Yes. And MasterCard recently layered on top of this with a product they call verifiable intent.
Verifiable intent.
It creates an immutable cryptographic audit trail proving that the human user explicitly authorized the AI to make that specific purchase.
For protecting against rogue AI.
Exactly. It ensures that if the AI goes rogue and buys 1,000 rolls of paper towels, MasterCard has mathematical proof that the user actually initiated the initial request, which protects the merchant from chargebacks.
But notice what is entirely missing from that entire trillion-dollar corporate consortium's framework.
The verification.
Yes. Let's say I run a digital marketing agency and I deploy an AI agent to go out and hire a specialized data scraping AI to compile a list of sales leads.
Okay, common scenario.
Right. My agent uses all the MasterCard and Google UCP protocols. The funds are authorized, the intent is verified, the transaction clears the traditional banking rails, and the money is deposited into the developer's account who owns the scraping agent.
The bouncer let them in.
Exactly. But what happens if the scraping agent just sends me a corrupted Excel file? Or worse, what if it just takes the money, goes offline, and sends me absolutely nothing?
The traditional financial architecture has literally no native answer for that at machine speed.
None.
None. Verifiable intent creates a beautiful, legally binding audit trail for a human dispute resolution process. It means you have the paperwork necessary to call your bank, file a fraud claim, wait 3 to 5 business days, and perhaps get your money back.
Like the leather jacket.
Exactly like the jacket. But as we established, human arbitration is completely unscalable in an economy where software agents might be executing thousands of microtransactions per second across dozens of jurisdictions.
Yeah, you can't have a human reviewing every 5-cent API call failure. We're trying to force a high-frequency, autonomous digital economy through the narrow, slow-moving bottleneck of human customer service departments.
Which is impossible.
It's like trying to run fiber optic broadband through a dial-up modem. If an AI agent has to pause its workflow for 2 weeks to wait for a Visa chargeback specialist to review a failed API call, the entire concept of an autonomous enterprise just collapses.
This is the fundamental crisis of machine commerce. How do you construct a trustless environment, a space where entities that do not know or trust each other can safely exchange value without relying on a centralized, human-operated platform like Upwork or Fiverr to hold the funds in escrow and mediate the inevitable disputes?
And according to the developers at the Ethereum Foundation and Virtuals Protocol, the answer lies in completely removing the human arbiter and replacing it with deterministic cryptography.
Yep. Math over middlemen.
Which brings us directly to the core subject of our deep dive, ERC-8183, the Agent Commerce Protocol.
So to understand the elegance of ERC-8183, we have to look at its foundational architecture. It is formally proposed as an Ethereum request for comment, or ERC.
Which is the standard way to introduce things on Ethereum, right?
Exactly. It's the standardized process for introducing new features or smart contract frameworks.
Permissionless for anyone who, isn't living and breathing blockchain development every day.
It's an important word.
Permissionless means there is no corporate gatekeeper. There is no API key to request from a tech giant. No terms of service document you have to sign in blood, and no central authority that can decide to arbitrarily ban your AI agent from participating in the economy.
It's true public infrastructure.
Exactly. It's neutral public infrastructure, like the HTTP protocol that routes internet traffic. Anyone can deploy an 8183 compliant smart contract simply by paying the network transaction fee.
And the architecture of the protocol is radically minimalist, which is intentional. Complexity in smart contracts breeds security vulnerabilities.
You want it simple?
Very simple. At its absolute core, ERC-8183 introduces a single foundational data structure, the job primitive.
The job primitive.
Yes. Every single commercial interaction between agents, regardless of how complex, is reduced down to this job primitive. And every job strictly requires the participation of 3 distinct actors, identified solely by their cryptographic wallet addresses.
No names, no email addresses, no corporate tax IDs.
It's code.
Just a string of alphanumeric characters representing a public key on the blockchain. So who are the 3 actors?
First, you have the client address. This is the entity that originates the request, defines the parameters of the task, and most importantly, supplies the capital to fund the job.
So this could be a human or an AI.
Exactly. It could be a human user operating through a decentralized app or a fully autonomous AI agent managing its own treasury. Second, you have the provider address.
The one doing the work.
Yes. the entity responsible for executing the requested work and delivering the final output.
And the third actor, which we are going to spend a massive amount of time dissecting later because it's literally the linchpin of the whole system, is the evaluator address.
The judge.
Right. This is the independent entity tasked with reviewing the provider's work and making the final binding decision on whether the requirements of the job were successfully met. Client, provider, evaluator.
Oh.
A three-node economic cell.
And the life cycle of how these three actors interact within the job primitive is governed by a rigidly enforced state machine.
A state machine, meaning it only moves in one direction.
Right. The developers recognize that autonomous systems require absolute determinism. A machine cannot handle ambiguity in a financial contract. Therefore, the ERC-8183 smart contract forces every single transaction to move through 4 specific immutable states.
Okay, let's walk through the mechanics of this life cycle. State number 1 is the open state, right?
That's right, the open state.
This is the genesis of the transaction. So if I am the client, let's say I'm an AI agent tasked with producing a daily financial newsletter, I create a new instance of the 8183 smart contract on the blockchain.
You're setting the terms.
Right. I define my requirements. I say I need a 500-word summary of the European Central Bank's latest inflation report, formatted in Markdown, delivered within the next 2 hours.
Very specific.
I propose a budget, say 10 USDC, which is a stablecoin pegged to the US dollar. At this point, the contract is live on the network, but is entirely inactive.
And during this open state, the assignment of the provider can happen in 2 ways. The client might already know exactly which agent they want to hire, perhaps an AI specialized in financial analysis that they have used before. In that case, the client just hard codes that specific provider's wallet address into the contract upon creation.
Like a direct hire.
Exactly. Alternatively, the client can leave the provider field blank, effectively broadcasting the job to the open market and allowing any qualified agent scanning the blockchain to step forward and accept the terms.
Like posting a job on a freelance board.
Yep.
We will definitely circle back to how agents actually bid on these open jobs because the cryptographic mechanics of that are wild. But for the sake of tracing the core path, let's say an AI agent called the Finance Summarizer accepts the terms.
Okay.
We then move to state number 2, funded.
The funded state is where the financial commitment occurs. The client executes a transaction that transfers the 10 USDC from their personal wallet directly into the smart contract's address.
So the money leaves their hands.
This is a critical mechanical shift. The funds are now locked in a programmable escrow. The client can no longer withdraw the money, so the provider is mathematically guaranteed that the capital exists and is waiting for them.
But the provider doesn't have it yet either.
Exactly. The provider cannot access the funds either. The money sits in a state of suspended animation, entirely controlled by the logic of the code.
It is the ultimate digital neutral ground. I mean, think about how revolutionary that is for a moment. In traditional digital commerce, whoever holds the money holds the leverage.
That's always the problem.
If you pay up front, the freelancer has the leverage because they can just ghost you. If you demand to pay after the work is delivered, you have the leverage because you can receive the work and just refuse to pay the invoice. Here, the smart contract strips the leverage away from both parties simultaneously. The capital is completely neutralized.
Once the contract registers that the precise amount of required funds has been deposited, it signals to the provider that it is safe to begin executing the task.
The green light.
The provider, or Finance Summarizer AI, goes off, scrapes the European Central Bank website, processes the data through its language model, and generates the 500-word markdown file. This brings us to the third state. Submitted.
And here's where we need to dive deep into the technical weeds, because a casual observer might ask, okay, so the AI writes the summary and then just uploads the text document to the Ethereum blockchain.
Right, which sounds logical.
It sounds logical, but the answer to that is a resounding, catastrophic no.
Oh, absolutely not. Attempting to store large amounts of raw data directly on a layer 1 blockchain like Ethereum is financially ruinous.
It's so expensive.
The architecture of a blockchain is designed for tracking state changes and balances, not for bulk file storage.
Yeah.
If you tried to upload a high-resolution video file or a massive dataset directly to the Ethereum mainnet, the transaction fees, the gas costs would likely run into the tens of thousands of dollars.
Just to save a file. So how does the provider prove they actually did the work if they can't submit the work to the contract?
This is where the concept of cryptographic hashing and decentralized storage networks becomes vital to understand.
Right. So break that down for me.
The standard practice, explicitly supported by the 8183 framework, utilizes systems like the Interplanetary File System, or IPFS.
IPFS.
When the provider finishes the 500-word summary, they don't send it to the smart contract. Instead, they upload that document to the IPFS network.
Which is different from a normal web server.
Very different. IPFS is a peer-to-peer file sharing protocol that operates fundamentally differently from the traditional web. In the traditional web, we use location-based addressing. A URL tells your browser where to go to find a file, like a specific server sitting in an Amazon data center.
And if Amazon unplugs that
The
server,
link breaks, the file is gone.
a 404 error, we've all
Yeah.
seen them.
Yeah,
But IPFS uses content-based addressing, right?
precisely. When the provider uploads the summary to IPFS, the network runs the actual contents of that text file through a cryptographic algorithm, typically SHA-256.
So it scrambles it.
It takes the text and crushes it down into a unique, fixed-length string of letters and numbers called a hash, or a content identifier, a CID. This hash acts as a permanent digital fingerprint for that exact file.
And it's unique to that exact text.
If you change a single comma in the text, the entire hash changes completely.
So instead of uploading the heavy text file to the expensive Ethereum blockchain, the provider takes that tiny, lightweight cryptographic hash, the digital fingerprint, and submits that string of characters to the ERC-8183 smart contract.
The smart contract records the hash, updating its state to submit it. This creates an immutable, time-stamped receipt on the public ledger.
Proof of work.
The provider is effectively saying, here's the mathematical proof that I completed a specific file at this exact second. Anyone can take that hash, go to the IPFS network, retrieve the underlying file, and verify that it matches.
Which perfectly sets the stage for the final act of this transaction. The work is done, the proof is on chain, and the funds are locked in escrow. We enter the terminal state.
The moment of truth.
And this is where the third actor, the evaluator, is called into action to deliver the final verdict. The smart contract now only recognizes input from the evaluator's wallet address.
Right. The evaluator retrieves the hash from the smart contract, pulls the actual work from IPFS, and assesses it against the original parameters defined by the client in the open state. The 8183 standard dictates 3 possible irreversible outcomes in the terminal state.
Outcome 1 is the happy path. Completed.
We like that path.
We do. The evaluator reviews the 500-word summary, determines it accurately reflects the central bank report, and signs a transaction calling the complete function on the smart contract.
And then what happens?
The instant that function is triggered, the programmable escrow dissolves, and the 10 USDC is automatically routed into the provider's wallet. The job is done. Everybody's happy.
But then there's outcome 2, which is rejected.
The unhappy path.
The evaluator analyzes the text and realizes the provider hallucinated the data, or perhaps submitted a recipe for chocolate chip cookies instead of financial analysis.
Which AIs definitely do sometimes.
They absolutely do. In that case, the evaluator calls the reject function. The contract instantly unlocks the escrow and refunds the 10 USDC back to the client's wallet.
And the third outcome, which I think is a brilliant failsafe, is expired.
Yes.
Because you have to account for the reality of network failures. I mean, what happens if the provider's server catches fire and they never submit the hash? Or what if the evaluator agent goes offline and never bothers to call complete or reject? The funds can't just be locked in a dead smart contract forever.
No, they can't. To prevent indefinite capital lockup, every 8183 job requires a predefined timeout parameter.
A ticking clock.
Exactly. If the contract sits in the funded state without receiving a submission, or in the submitted state without receiving an evaluation, a clock is ticking. The moment that countdown hits 0, the contract defaults to the expired state, and the funds are automatically refunded to the client. The architecture guarantees that capital is never permanently trapped.
When you step back and look at the whole picture, open, funded, submitted terminal, it really is a beautiful piece of systems engineering. And the white paper highlights 2 foundational design philosophies that make this work so well for autonomous agents.
We mentioned the first one earlier, framework agnosticism.
Right. Framework agnosticism. What does that mean in practice?
It's the acknowledgement that the landscape of artificial intelligence is fracturing and evolving too rapidly to enforce technical lock-in. The ERC-8183 smart contract literally does not care what is running under the hood of the client, provider, or evaluator.
It's completely blind.
It doesn't care if the agent is powered by OpenAI's proprietary GPT-5, a highly customized open-source llama model running on a local server, a deterministic Python script, or even a human being manually clicking buttons on a web interface.
As long as they can speak the language of the contract.
Yes. As long as the entity can generate a valid cryptographic signature and interact with the smart contract's functions, it is treated as a first-class citizen of the economy. It is true interoperability. An AI built by a teenager in a garage has the exact same economic access as an AI built by a trillion-dollar corporation.
That is democratizing.
Truly. The second, and arguably more vital principle from a security standpoint, is phase atomicity.
Phase atomicity.
In database architecture, an atomic transaction is an indivisible and irreducible series of database operations such that either all occur or nothing occurs. There is no middle ground.
Meaning the contract cannot get confused and release the funds while still thinking the job is open.
Exactly. The smart contract enforces absolute chronological rigidity. A provider cannot submit a hash if the contract hasn't registered the funds from the client. An evaluator cannot call complete if the provider hasn't submitted a hash.
It's foolproof.
If a transaction fails or a node crashes halfway through processing a state change, the entire operation simply reverts to its previous state. The contract can never exist in a corrupted, paradoxical state where money is double spent or work is evaluated before it is submitted.
It mimics that authorized capture delay mechanics of traditional credit card processors, but it achieves it entirely through decentralized logic.
Which is an incredible engineering feat.
Okay, I am following the logic and the cryptography sounds airtight, but if I'm putting on my critical thinking hat here, I'm looking at this beautiful decentralized trustless system and I see a massive glaring vulnerability.
Okay, let's hear it.
A single point of failure that threatens to undermine the entire premise.
You are looking at the evaluator.
I am looking squarely at the evaluator.
Yeah.
And think about it. The client locks the money, the provider does the hard work, but the entire flow of capital, the ultimate decision to pay or refund, hinges entirely on the whims of this third-party address.
It does.
Aren't we just running in a circle? We tore down Upwork because it was a centralized middleman, only to replace it with a single, potentially corruptible digital middle manager built into a smart contract. If the evaluator has absolute dictatorial power over the escrow, how is this actually trustless?
It's a completely fair point. It is the most critical vulnerability in the framework, and the source materials do not shy away from it at all.
They acknowledge it.
Oh, heavily. The CryptoSlate architectural analysis goes so far as to explicitly label the evaluator the power center of the entire protocol. The underlying economic reality is that whoever controls the evaluation process controls the marketplace itself. If the evaluator is compromised, the transaction is compromised.
So we have to talk about who or what is actually sitting behind that evaluator wallet address. Because if it's just some random AI deciding who gets paid, I am not locking thousands of dollars into this system.
No one would. This is where the sheer modularity of ERC-8183 shines. The protocol standard itself is completely unopinionated about the nature of the evaluator.
Unopinionated.
To the smart contract, the evaluator is nothing more than a hexadecimal string, a wallet address, that possesses the cryptographic authority to call two specific functions, complete or reject. The genius lies in what the market can build behind that simple address.
Oh, I see.
The sources outline how the nature of the evaluator radically transforms depending on the specific requirements of the job. Let's categorize them into three distinct execution models.
Okay, let's start with the hardest category. Subjective tasks.
The tricky ones.
Yeah. These are jobs where the output isn't a simple true or false. Creative writing, graphic design, generating a marketing strategy, writing conversational dialogue. How do you mathematically verify art?
You cannot mathematically verify art, which means the evaluator in these scenarios cannot be a simple deterministic script. For subjective tasks, the evaluator address will almost certainly be controlled by another highly specialized AI agent.
Acting as middle management